this traditional way is good for school, but it is not good for competitive exams where time is very important. So in today's video, we will learn a shortcut in which you will be able to solve bond order question within 2 to 3 seconds. Hello everyone, I am Apurv and welcome to ATP STEM. In today's video, we will learn how to quickly solve any question of MOT bond order quickly within seconds. Now the traditional way of solving bond order questions is to write the full electronic configuration and then count the number of bonding electrons, number of anti-bonding electrons, subtract the two values, divide it by 2 and you will get the bond order. This traditional way is good for school, but it is not good for competitive exams where time is very important. So in today's video, we will learn a shortcut in which you will be able to solve bond order question within 2 to 3 seconds using a table which you can see on your screen. So in order to apply this shortcut, you need to calculate number of electrons present in the molecule and then just have a look at this table and then you can calculate the answer very quickly. For example, if number of electrons are 14, bond order is 3. If number of electrons are 3, bond order is 0.5. If number of electrons are 20, bond order is 0. So if you just count number of electrons and if you find a way of remembering this table, writing this table very quickly, then you can calculate the answer in seconds. Now I'll teach you a simple way by which you can make this table and learn this table very quickly for your exams. So the way of learning is just remember that when number of electrons are 14, the bond order is 3, and if number of electrons reduce by 1 or increase by 1, for each successive increase or decrease, the bond order reduces by 0.5 successively. So when number of electrons are reduced by 1, from 14 to 13, bond order reduces by 0.5. Again, if you reduce the number of electrons by 1, bond order reduces by 0.5 once again. If you again reduce the number of electrons by 1, bond order reduces by 0.5 once again. This keeps on happening till 8 when the bond order becomes 0. Similarly, when you increase the number of electrons by 1 from 14, if you make the number of electrons 15, again the bond order reduces by 0.5. So from 3 it becomes 2.5. If you make the number of electrons 16, the bond order becomes 2. If you make the number of electrons 17, bond order again reduces by 0.5, it becomes 1.5. If you increase the number of electrons by 1, 18, bond order again reduces by 0.5, it becomes 1. This keeps on happening till 20, and in our portion for JEE and NEET, only 20 electron species at maximum can come in your exam. So you can remember this technique for number of electrons from 8 to 20. What about the molecules which have electrons less than 8, from 1 to 7? What to do in those molecules? How to learn the table for that? For that also I'll give you a very simple way. For that, just keep on writing 0.5, 1, 0.5, 1, 0.5, 1, 0.5 alternatively. With just one exception of number of electrons 4, then instead of 1, you should write 0. So for 1 to 7, it is even easier. You just need to write 0.5, 1, 0.5, 1 alternatively with one exception. When number of electrons are 4, at that time instead of being 1, the bond order is 0. So by using this table, you will be able to calculate bond order very quickly within seconds. And once you calculate the bond order, rest of the things also you can arrange in descending or ascending order as per the question, because bond order is directly proportional to bond strength and it's directly proportional to bond energy. More the bond order, stronger will be the bond and more will be the energy needed to break the bond. Similarly, stronger will be the bond, closer will be the atoms and lesser will be the bond length. So using the table and these two relations, we can solve almost all the questions coming on this chapter in JEE or NEET. Let's start solving some questions. So let's first of all solve some bond order calculation questions. So let's first of all calculate bond order of NO. So how many total electrons are there? Nitrogen has 7 electrons, oxygen has 8 electrons. So total number of electrons are 15. When total number of electrons are 14, then the bond order is 3. When number of electrons increase by 1, when they become 15, bond order reduces by 0.5. So from 3, the bond order will become 2.5. See, so quickly, no need to write sigma 1 is 2, sigma star 1 is 2, then counting number of bonding and anti-bonding electrons. This shortcut is going to save a lot of your times, guys. You can thank me for that in the comment section. Let's do another question. Let's talk about CO. Now in CO, how many electrons are there? Carbon has 6 electrons, oxygen has 8 electrons, so number of electrons are 14. And when number of electrons are 14, bond order is 3. Right? Easy. Let's move on to the third question. In N2, how many total electrons are there? 14. When number of electrons are 14, bond order is 3. Right? Let's move on to O2. In O2, how many total electrons are there? Each oxygen atom has 8 electrons. There are 2 oxygen atoms, so I am multiplying it with 2. So total number of electrons are 16. Again, when total number of electrons are 14, bond order 3. 15, 2.5. 16, 2. So easy. Let's move ahead to O2, 2 minus. Now, each oxygen atom has 8 electrons. Each oxygen atom has 8 electrons. There are 2 oxygen atoms. Then we have 2 minus, right? 2 minus means there are 2 more electrons, right, than usual. So we'll add 2 electrons to compensate for that. So total number of electrons are 18. And using the table, we can find when total number of electrons are 18, the bond order is 1. I'll show you in the table very quickly. Total number of electrons 18, bond order 1. See, you can solve any bond order question using this table, right? All right, let's move ahead. Let's do a few more questions on bond order. O2 plus, similarly, total electrons 15, bond order 2.5. One more question, B2, total electrons 10, bond order 1. Now let's do some question in which we have to relate bond order, bond strength, bond length, bond energy. Let's do one question based on that. So in this question, everyone please carefully read the question. We have been given 3 species. For these species, we have to arrange in descending order of bond order, bond strength, bond energy, and bond length. First of all, in these types of questions, find bond order. So how to find bond order? Shortcut, right? So in case of N2, how many electrons are there? 14. For 14 electrons, bond order is 3. In case of N2 plus, how many electrons are there? 14 minus 1, 13. So when total electrons are 13, bond order is 2.5. In case of N2 2 minus, total number of electrons 14 plus 2, 16. When total number of electrons are 16, bond order is 2. So we can clearly see that 1 has the highest bond order, then 2, then 3. Let's write that down. 1 has the highest bond order, then 2, then 3. And bond order, as I had explained earlier, bond order is directly proportional to bond strength and bond energy. So same order will be there for bond strength and bond energy, right? Now bond length is inversely proportional. So for that, the order will get reversed. So it's so easy to solve MOT questions and it saves a lot of time. It's free marks actually. In exam, if this type of question comes, it's free marks. Now one more type of question which is usually asked in MOT is if a given molecule is diamagnetic or paramagnetic. So there is a shortcut even for that. Count total number of electrons. If total number of electrons are odd, molecule is 1000% paramagnetic. But if total number of electrons are even, then we have to be careful. It is usually diamagnetic, but for some cases, it can be paramagnetic also, especially for these 2 exceptions. One is B2. B2 has 10 electrons. So it is even number of electrons. So it was supposed to be diamagnetic, but in reality, it is paramagnetic. Similarly, for O2, total electrons are 16. It's supposed to be dia, but it is paramagnetic. We are done with this shortcut as well. Let's quickly go through some of the molecules which we discussed earlier and figure out if they are diamagnetic or paramagnetic. So in this question, N2 has 14 electrons, even number of electrons, so N2 is diamagnetic. N2 plus 13 electrons, odd electrons, paramagnetic. N2 2 minus 16 electrons, even electrons, diamagnetic. So I hope you have understood all the shortcuts, you enjoyed the session. This is it for today's video. If you understood everything, if you learned something new, please don't forget to like and subscribe the channel. Stay tuned for more videos and I'll see you around in our next videos. Bye bye guys. Take care. Thank you.